Back on our sample vulnerable web application, I want to start looking at how we can mount a successful union-based injection attack. So again, how can we take a legitimate set of results already returned by the web application and append a set of results that we instruct the database to give us that the web app normally wouldn't return? And of course, we're going to do that with the union operator. Now, as I just said in the previous clip, the thing that's predicated on making this successful is knowing what columns to return in the second select statement. Because if we don't return the same number of columns as in the existing select statement, so the one returning the results in front of us here, it's not going to work. We'll get an exception. Now, of course, this page, as we now know, is also vulnerable to error-based SQL injection. So if an exception was raised, we'd actually see it here in the browser. And we're going to use that to our advantage in just a moment. So let's try doing this. We're going to jump up here into the address bar again, and right up the end of V12, we're going to close that statement off again. So remember, that'll close the string and allow us to start entering our own SQL syntax afterwards. Now what I want to do is jump straight into this union. So we'll use the union operator, and now we can create our own SQL query. And what I want to try and do is I'm going to select star, and I'm going to select that from, and here is now the point where we've actually got to know what we're going to select it from. So we need to know the name of another internal table that we want to retrieve in the results. Now very shortly, I'm going to show you how to discover that internal schema using SQL injection. But for now, I'm going to make it a little bit easy. In this application, you can vote on these vehicles. And it would be a fair assumption to make that if you can vote on something, there is probably going to be a vote table. So here's the thing with injection, you can guess. And if we get it wrong, again, this does have an error-based injection risk. It will tell us we've got it wrong. But most of the time you'll find that there are underlying entities that are named semantically in line with the entities that you see in the app. So it's very likely there's going to be a vote table. It might be votes, it might be pluralized depending on the convention that the developer followed, but we're just going to go with vote. And of course, as we saw in the previous module, we'll put in a dash dash to simply comment out any SQL that occurs after this is actually concatenated into the SQL statement. And now let's run this. And here we go. We've got an error. So thank you very much to error-based SQL injection. And this error is the same as what we just saw in SSMS when we didn't have the correct number of columns. So the question that we've got to ask ourselves now is how many columns is the original SQL statement returning? Now there are a number of different ways that we can discover this, and I want to show you two right now. And one of them is just simply using a bit of common sense. So let's go back, and I'm going to view the source of this page. So I'm going to do a Control U, brings up our HTML source. I'm going to scroll down a little bit because I want to see where the results for these cars are. And we can see in the HTML markup here, we've got a div, and within this div, we've got the LaFerrari. So we can see the alt tag just here on line 67. Above that, we can see the Pagani Huayra, and below that, we can see the Aston Martin 177. They all follow this same sort of pattern. But here's the thing, I'm interested in what data is being displayed on this page because that is going to give us a pointer as to what columns might be returned by the underlying query. So I can see really two different data attributes for the supercar. So I can see the name of the supercar here, or the model as it may be, so LaFerrari. And I can also see an ID just here, so ID number 4. So that's two columns. But one of the problems with this as well is that 4 is an integer, LaFerrari is a string, so we don't necessarily know which order they're in, and we also don't know if perhaps the query is actually returning other columns that simply aren't used in the source code here. So let's do this. I'm going to close this tab. We'll go forward again to bring up our query from before, and we can now jump into where that star is in that SQL injection attack in the URL The percentage 20s either side of that are just URL encoded spaces. So Chrome has effectively taken the space and encoded it for us. Now we can replace that star with what we might guess to be two different columns from the vote table. That's if 2 is right. But there's a really easy way to test this. And the way we can do it is just to type in an integer, and then a comma, and then another integer, and run that. Now this actually tells us something interesting. So we've got a type conversion error here. The specified cast from int32 to string is not valid. So what seems to be happening here is that we've put two integers in the select list here. Now we're unioning this select statement on the end of another select statement. And inevitably that other select statement is returning a string somewhere. And when it gets union with the integer, we get the exception that you see here. So what we can try doing is just changing one of these from an integer to a string. So let's maybe just put a single quote on either side of the second value, just like this. Now this is interesting. And it's interesting because we've now got the Nissan GT-R up here, and it's got the number 1 underneath it. Now one of the things that's really handy when looking at the results that a web application is returning is the developer tools in the browser, and in particular the page inspector. So if we right click on this GT-R and we inspect the element, we can see here the number 1, and if we have a look in this thumbnail container, we can also see a hyperlink here to Supercar 1, and in there the image with number 1. So what's actually happened is we've got this select statement unioning to the existing select statement and simply selecting one more row with an integer value of 1 and then a string value of 1. And of course that 1 is encapsulated in single quotes that have been URL encoded. So what this is actually telling us is that the existing SQL query on this page is returning a result set that consists of an integer and a string. Now before, when we looked at the source code and we looked at LaFerrari, it would be safe to assume that the integer is the ID of the supercar and the string is the name. So we've now established the pattern. And again, this is a very manual guesswork way around figuring this out. And we'll look at how to extract this information from the database properly as we progress through this module. But let's get back to vote. What we really want to get from vote is columns from the internal vote table. Now it's probably a fair guess that there's going to be a column called vote ID. It's probably either going to be vote ID or ID. So again, these conventions are things that are worthwhile being aware of because we see the common patterns over and over and over again. Now, one of the things I know about the voting mechanism of this website, simply by browsing around it, is that every time you vote, you can also leave a comment. So let's try and do this. I'm going to take out the string number 1 and the integer number 1, and I'm going to try and grab a column called vote ID and a column called comments. Now let's try and run this. And here we now have a very different set of results. And in fact, if we scroll down a bit, we can see we've got all sorts of things here in amongst our supercars. Now here's what's actually happening. We're getting a whole bunch of legitimate supercars. So all the normal ones in the system, that comes back from the original query. But we're then appending all the votes. And for every vote, we're getting a vote ID and we're getting the comments on the vote. So we're seeing things like this. I love the color. That's an existing comment in the system. Is this for real? Another comment in the system. Now the reason why we're seeing a broken image over here is that if we inspect this image, we see down here that it's being referred to as supercar number 19. Now what's actually happening is that we're getting the vote ID number 19, but there is no supercar of number 19. There's less than 19 cars. So consequently there is no image for supercar 19 and we're seeing a broken image. Now that doesn't matter because what we really want to focus on is the data. So what's important is seeing these internal comments, things like this. That is a comment in that votes table, and we've just managed to spit it back out to the UI simply by appending it with the union operator. Now this is enormously powerful stuff, and so long as we know what the internal table structure is, so we know that there's a vote table that has a vote ID column and a comments column, we can get that data out and put it on this page. Doesn't matter how messy it looks, the point is that we can get the data itself. So how are we going to discover what those internal objects are? The tables, the columns? Well, there's a couple of ways. We guessed what's here in the URL now. Let's move on and start looking at some manual testing to discover what those underlying objects really are.